Welcome to this tutorial on audio patchbays. The concept of an audio patchbay is easy to understand. Almost all studio equipment interconnects via leads plugged into sockets which are usually located on their rear panels. If you need to change these connections, you must first remove and reconnect the leads. So why is this a problem? Well, firstly, you may have difficulty in getting to the connections if your equipment is sited against walls or located inside cabinets. Secondly, you may find that your leads are not long enough for the new connections you want to make. Thirdly, it may not be immediately apparent which piece of equipment is connected to which, and patchbays can be labelled. And lastly, your creative flow may be interrupted if you need to stop to reconnect your equipment. The solution is to run all the leads from your equipment to a centrally located series of sockets called a patchbay. Equipment can then be easily reconnected with short leads called patch cords. If you don't regularly change the routing of your equipment, you may not need a patchbay, but it is likely that you will benefit from some of your equipment's interconnections being easily accessible. For example, you may want to use an outboard compressor to control dynamics when recording with a microphone, and then the same device again later to compress an instrument during mixing. The most common use of an audio patchbay is to route mic and line level signals, and you can route other signals too. However, it is unwise to connect multiple types of signal to a patchbay, which, if accidentally patched incorrectly, could damage your equipment. For example, you would not want to connect the output of your power amplifier accidentally to the input of a delicate mic preamplifier. Therefore, it is sensible to assign some types of signal to their own dedicated patchbays and ensure that they are physically remote from each other. Although less common in the project studio, audio patchbays may also be used to interconnect power amplifiers and speakers. Also, there are specialist patchbays available for routing digital electrical, MIDI and optical signals. Audio patchbays are available in both balanced and unbalanced configurations. Even if you only have unbalanced equipment, you should consider buying a balanced patchbay. This is in order to make your studio future-proof, because the time will come when you acquire a balanced device. Also, it's worth knowing that a balanced patchbay can be used with unbalanced signals, but an unbalanced patchbay cannot be used with balanced signals. Audio patchbays may be categorized by the three different front panel connector types they use. Firstly, Type A jacks. These use the standard musical instrument, keyboards, guitars, etc. and semi-pro recording equipment 1/4 inch A-gauge jack plug connector. Although convenient, instruments can be connected without the need of a conversion lead. A-gauge jacks were never designed for heavy patchbay use and should be avoided if you plan to regularly repatch your equipment. 2. B-gauge GPO jacks. These connectors were used in the early days of telephone exchanges when connections were made manually by operators. They are very robust and hard-wearing. The plug is physically similar to Type A, but the tip is shaped differently and the construction is generally more robust. You should never insert a Type A gauge jack into a Type B gauge socket. And lastly, Bantam jacks. Essentially a mini version of the Type B GPO jack, developed by mixing desk manufacturers to allow a greater density of sockets in a small area. Manufacturers offer a variety of rear panel connector types. Firstly, solder terminals. Solder terminals are reliable and cost-effective, but reconfiguring a patchbay may take longer. 1/4 inch A-gauge jack connections are convenient. but connections can become intermittent, need cleaning, and it does inflate the purchase cost. D-sub 25 pin connectors. These kind of connectors can be useful if your devices have them also. And lastly, EDACs. EDACs are an established multi-pin connector that is commonly used in live performance, and again are convenient if your devices have the same connector. The rear of the patch bay should feature a tie bar to connect looms to and prevent strain on the connections. To minimise the need to use patch leads for every connection, normalisation is a wiring configuration whereby vertically adjacent sockets are permanently connected together even when no lead is plugged in. This allows you to have default connections which can be changed when required. An example would be to have the outputs of a CD player connected to two sockets in an upper row and the inputs to a mixer's 2-track monitor return connected to two sockets in the row below, and have these connections normalised so that the devices are permanently connected. The connection would only be broken when patch leads are inserted into the top row sockets, perhaps in order to send the CD player output to a sampler. There are 4 primary normalisation configurations. 1. No normalisation, sockets are not connected. 2. Normalisation, vertically adjacent sockets are connected when no patch cord is present. When you insert a cord, the connection is broken. 3. Half normalisation, vertically adjacent sockets are connected when no patch cord is present, but when you insert a cord, the connection is maintained and an additional feed of the signal is taken. And finally 4. Parallels. Multiple sockets are permanently connected so that copies of signals can be taken. Most patch bay designs allow you to normalise vertically adjacent sockets by either changing the alignment of a PCB or performing a simple solder. There are no absolute right or wrongs in how you choose to set up a patch bay, but the following are some of the standard practices employed by professional installation engineers. Create a list of all necessary connections and equipment. Group rows of sockets into categories, e.g. mixer inputs, stage box connections and audio interface connections. Create a diagrammatic illustration of the patch bay. Alternate between rows of outputs and inputs, outputs above and inputs below, and ensure that connections that are to be normalised are vertically adjacent. The script for this tutorial, with accompanying screenshots, can be found at projectstudiohandbook.com. And finally, please don't forget to subscribe to our YouTube channel or at the website to get instant notification of new videos as they are uploaded. And please do click on the ads of interest to you. We're a free resource and they help to pay our costs. Thanks very much for watching.